Yeah, okay. So I'm sorry about the lighting up there. That light is not working, so I have to turn this one on, and because of that, well, we're stuck with this. So sorry about the lighting. And yeah, let's get started with the theory portion of Cartesian products. So we have an arbitrary indexing set, and we have a collection of sets, right? And we have a function from this indexing set to a collection of sets, right? And this function is surjective. And all of this together is called an indexed function index set, I think. Doesn't really matter. Yeah, indexed family of sets, nothing much. So, and it's also denoted by, so f of alpha is equal to a of alpha. Typically, that's how it's denoted. And yeah, it's denoted as a alpha, alpha belongs to j, something like that, right? So yeah, the indexing function set could be anything, and the function could be also virtually anything. That matters is that the function is surjective. So yeah. And we have an alternate and equivalent definition for arbitrary unions and intersections. So how does it write it? Yeah, union alpha belongs to J, A alpha is equal to, well, it has to belong to at least one, right? X. There exists alpha belongs to J such that X belongs to A alpha, pretty much. Checking. Yeah. And yeah, for intersection, alpha belongs to J, A alpha is equal to X. For all alpha belongs to J, X belongs to A alpha. So yeah, it's literally just this. And yeah, that I guess there's a connection of the or and operator, and there exists and for all quantifier, I guess, if you want to look at it that way. So yeah. Okay, what else? Yeah, so we have notations for the finite sets. If the index set happens to be a 1 to n, then we have a notation. Yeah, an M tuple. So an M tuple is simply, I'm going to call it a vector sometimes, doesn't matter much. It is a function from 1 to M to a set. So it has to be a collection of sets, right? Pretty much. And so it's not the collection, sorry. It's going to be the union. And essentially, xi belongs to ai. So I guess it's index by. Yeah, there you can see it, I hope. Hang on. Yeah, we have it defined from I to x, I guess. So that's fine. X and yeah, xi, which is a function. So xi is equal to x of I, which is a natural number. Yeah. And well, yeah, that's it, I guess. That's called an M tuple. And yeah, so yeah, if we have a family of sets, okay, so there is another notation introduced here. For this, we have phi AI. It's the same thing what the book writes. Yeah, the set of all M tuples. And any M tuple here would be, well, xi would belong to AI, essentially. Okay. Now we have an omega tuple, which essentially just changes the m to a z plus, right? So we have a function that way, and yeah, the set of all m tuples here is called x to the power m, and if it's z plus, then it's called x to the power omega if it's the same set, and if it's not, then we have pi. What is it? Yeah, I belongs to z plus ai. Yeah, it's just mostly definitions and notation. There's not much to be studied in this chapter, to be honest. So, yeah. Hey, yeah, the notation's consistent. Yeah, there's nothing too new here. Just read the book, I guess.